Welcome back. In this video we are going to look at how to verify identities. Okay? Now there are two methods that you can work with. The first method is to start with the right or left side of the equation, and you want to just simply make it look like the other side. The second method is you have to work with each side individually, and you keep simplifying or manipulating them until they end up looking the same. Okay? The biggest hint that I can give you in terms of working with these is try to work with what looks to be the more complex side first, and try and simplify that down as far as it can go. The other thing or hint that I could give you is that if you can relate or translate everything into a sine or cosine expression, a lot of times that helps you with simplifying things down to be able to verify it. The next biggest hint I can give you is look for any algebraic manipulations you have, meaning add, subtract, multiply, divide, and the big one that tends to be forgotten, factoring. Don't forget you also have all of the Pythagorean identities which you can look for, which also help you rewrite your expressions in terms of a different form. Okay? So the easiest way to show how this works is just to jump right into some examples, and I've got a couple here for you. So first we need to verify the identity. So we have the cosecant minus the sine is equal to cosine cotangent. So we need to be able to verify that these are the same. So you need to start working with one side or the other. Immediately when I look at this, I see I have a cosecant, which automatically says that I can rewrite that. Cosecant is the same as 1 over the sine of x minus my sine of x. And when I look at the other side, I have this cotangent. So I also know that my cosine is going to stay, but cotangent can be written as the cosine of x over the sine of x. Okay. If I look back over at my left-hand side, I have a fraction added to another. So in order to do that, I need to remember common denominators. So this means that my common denominator here is a sine, so what's missing is a sine. So this is going to become 1 minus the sine squared of x all over that common denominator of sine, to which this equals the cosine squared of x all over the sine of x. Now, if you notice, this top piece right here looks to be very similar as one of the Pythagorean identities, which remember was sine squared of x plus the cosine equals 1. So if you look at this identity, if I subtract sine squared from both sides, is that not what I have? And in doing that would leave it equal to the cosine of x. So in this case, I end up getting the cosine squared of x over the sine of x is equal to cosine squared of x over the sine of x. Since both sides equal each other, I have finished. Okay, so verify the identity. Alright, let's look at another example here. One a little more complicated. So I have cosine beta cotangent beta over 1 minus the sine of beta, and the whole thing is minus 1, and that equals cosecant. So the first thing that I would do is I would want to go in and try and change everything over to sine and cosine. So I have a cotangent, which is the same as cosine over sine. So this becomes the cosine of beta times the cosine of beta over the sine of beta. This whole thing is over 1 minus the sine of beta. I'm subtracting 1. And then again I have a cosecant. Well, we know that to be 1 over the sine of beta. So since this right-hand side equals the sine of beta, what I'm hoping is that this whole mess on this left-hand side I can get to simplify down to that. So here I have to start working with what I have. Well, first and foremost, I have to combine my fractions. My denominator is 1 minus sine. So this is going to be the cosine of beta times the cosine of beta over the sine. This whole thing is over 1 minus the sine of beta. And I'm going to subtract 1 minus the sine of beta over 1 minus the sine of beta. And I am still hoping that I make that equal to 1 over the sine of beta. So let's continue to simplify. Across the top here I can multiply, so this becomes the cosine squared of beta all over my sine. Combining my fractions says I'm going to have minus 1 plus the sine of beta. Now, anybody who's confused, remember this was subtraction, which means this has to be applied to both parts on the top. Okay. So this whole thing is over 1 minus the sine of beta. And I'm still hoping that that's going to equal out what I want. So now I need to look just at my numerator and I need to combine it. My denominator is the sine. So this is going to become cosine squared of beta over my sine of beta minus the sine of beta over my sine of beta plus the sine squared of beta over the sine of beta, and that whole thing is still over 1 minus sine of beta. Whew, that's a lot. So I can go ahead and rewrite my numerator. So this is going to be the cosine squared of beta minus the sine of beta plus the sine squared of beta. This whole thing is over the sine of beta, again, which is still over 1 minus the sine of beta. If you look at the top, notice I actually have cosine squared of beta plus sine squared of beta. Well, this combined with this part here is actually Pythagorean's identity, which is 1. So I can actually rewrite my fraction here to saying 1 minus the sine of beta all over the sine of beta, and that whole thing is still over 1 minus the sine of beta, should equal what we wanted, 1 sine of beta. So if you look, we're almost there. I have fraction over fraction, so that says I can rewrite it to be 1 minus the sine of beta over the sine of beta times 1 over 1 minus the sine of beta, and we're hoping is going to equal my 1 over sine of beta. If you look, top to bottom cancels, and I end up with 1 over the sine of beta equals 1 over the sine of beta. And this has proven my identity. Whew, that was a long one. So here, if you paid attention or if you look closely, what you'll notice is from the beginning, what we started out doing is manipulated our fraction all the way down. So in this, what we simply remembered was our fraction rules. Which stated that to add or subtract, you need a common denominator. So all we simply did here is we just manipulated the fraction in order to combine them using the idea behind common denominators. All right, I got one more for you here because this one is going to use a cofunction identity. Okay, so here I have the cofunction of pi over 2 minus your theta. Now that is a cofunction identity. So cofunction identities okay, so here we've got cofunction identities, and so each one of these identities reduces down to a specific term. So here I've got cosine of pi over 2 minus x gives me the sine of x. So when I'm talking about this example here, I have the cosine of pi over 2 minus theta. So that's going to be the same idea. So automatically this is going to become the sine of theta over my cosecant of theta minus 1 equals your sine times your cotangent of the negative theta and then cosine of the negative theta. Okay. So we have to be able to continue to manipulate. Well, first thing and foremost, we know based on our negative rules that this is going to be the same as the cosine of theta. And my cotangent of negative theta is going to be the same as negative cotangent of theta. And so we need to start being able to manipulate our equation. We also know that the cosecant is going to be the same as 1 over the sine. So we can rewrite all of this to say that I have the sine of theta over 1 over the sine of theta minus 1 is equal to negative sine of theta cotangent of theta cosine of theta. Now when I look at my cotangent, I can rewrite that to say cosine over sine. And I have fraction over fraction, so that says keep the top and flip the reciprocal of the bottom. So this becomes sine of theta minus 1 equals negative sine of theta cosine over the sine and then cosine of theta. On this left hand side I have sine over sine, and so those will go away. And on this right hand side I've got two of them, so this ends up being sine squared of theta minus 1 is equal to negative cosine squared of theta. Well, the first thing that I would do is I would go ahead and rewrite my other side. So this is negative 1 plus the sine squared of theta equals negative cosine squared of theta. Now, if I divide everything by the negative 1, everything flips its signs. This becomes 1 minus the sine squared of theta equals cosine squared of theta. And here, if you remember from your Pythagorean identity, 1 minus the cosine squared of theta is going to be the cosine squared of theta equals cosine squared of theta, thus verifying your identity. So those are 3 examples, one more complicated than the next, all demonstrating how you would verify identities using the knowledge you have from your identity properties, your Pythagorean identities, and any other mathematical knowledge that you want to apply. So basically just comes down to manipulating both sides of your equation in order to get what you want. So if you have any questions, please let me know. If you feel like you need any additional examples, please feel free to let me know that too, and I would be more than happy to work some more out. Otherwise, I do hope you enjoyed yourself as much as I do. Remember to be as creative as you possibly can. and I will see you next time.